Hello everyone. This is a project named as function generator, square, triangular, and pseudo sine signal generator, done by me, MOHAMMED TALEB ZAMZAM, and MAHDI ABDULAZIM ALHAJ for the sake of electronic circuits course, Yildiz Technical University, MKT 2122. Before I start into details, and of course I will not get into the technical details, just I will explain what have we done. I would like to say that our biggest improvement, biggest achievement is that we made with almost $30 what is, as you can see, called function generator. Of course with a high quality and bigger range, but it's for $715. It starts from there. Now I will start into the explaining of the project. I will concentrate on the ideas that we put in this project. Normally the project is just this one, this simple circuit. In fact, it's not very simple, but this was the project. But together with these three units, we had, as I said, this almost the 715 bucks function generator. Okay, first of all, the first idea that we used, the object-oriented programming idea, that you divide all of your work into blocks that you can use each block alone. Okay, so I will start with my first block. This one was added by us. It was not needed in the project description, but we found it that it's very important. Okay, I will start explaining it. Okay, now it's plugged into electricity. As it's written, it's a DC unit. It's AC to DC converter, what's known for power supply from 0 to 13 volt, and using this potentiometer and small circuit. And this circuit normally is not that easy, but because it was my last term project, I used it now. Okay, so let's first of all check the functionality. It starts from low values reaching 13 volt. Okay, so what is the importance of this one? The importance of this one, that if this was not here, we will had to feed this circuit using a battery. What is the disadvantages? First of all, it will stay a small circuit if you used a battery. The second thing, that the amplitude of the signal, the voltage, will be constant because it depends on the battery. But now with this unit, we can see that I can put, first of all, if I put them in a case, I will get, as I said, 715 bucks function generator. Secondly, I can now control the amplitude of the signal, not only the frequency, because the function generator's first aim or purpose is frequencies, a higher range of frequencies. But now with this, together with the frequency, I can adjust the voltage of the signal. This is very important thing. Okay, the first unit now is working perfectly. Very well organized. The real circuit can be maybe just a thing of this long if we used other techniques like surface mounting, maybe PCBs, pref boards, and so on. Now we will move to the second unit, and it's the main unit. Simply, the main unit is the function generator using this IC 555 timer. So what's the aim? The aim that you can get signals, square type of it, triangular type of it, pseudo sine of it, with range of frequencies from 1 Hertz to 1 megahertz. This was the intended project. Okay, so I will not, as I said, get into details. I'll just explain the ideas. So my challenge is how to get this very high range. Our idea was like this. Using this switching capacitor, this is a switch, And as a mechatronics engineer, for example, as you can see this cover, because it's important for a mechatronics engineer to pay attention to the design. As you can say, it's somehow good looking. And of course, if I had the time, I would use the 3D printer to get a box, a very good looking box, very efficient box with no spaces for nothing. Anyway, we didn't have the time to do that. Now I will explain the circuits. Okay, first of all, this is the circuit of square wave. You will get from pin 3 the square wave. This is the circuit of triangular wave. This is the circuit for pseudo sine. Pseudo means not real sine wave. Not real, but very close. Okay, so in each thing we have to understand the two ideas that we put. We said, let's divide this interval from 1 to 1 megahertz into 6 intervals. How? From 1 to 10 hertz. From 10 hertz to 100 hertz. From 100 hertz to 1 kilohertz. So a power of 10 intervals is divided because it will be easier for us. Of course, for those who don't know how the 555 timer works, it might be hard for them to understand, but later they will understand what's happening. Anyway, now inside each interval, first of all, how to get these intervals? I will get them using this. I will now explain the switching circuit. Okay, I don't know if it's clear. Inside this one, we have a switch like this. Let's see if I have another one of it. Yes, exactly like this one. So this is a switch. You switch from you connect, for example, the circuit you have, and this is the common ground, and these are pins. You connect whatever you want, and for each switching, only one component will be connected, and the others will be open circuits. So this was the idea. We put 6 capacitors, and for each one, now we can get, if I move the switch, I will get a different connected capacitor, and for each capacitor it starts from 1 picofarad, 10 picofarad, 100 picofarad, 1 nanofarad, and so till we get 1 microfarad, and each one of them will give me that power of 10 interval. Okay, so that was a good idea, because for the other cases I will, for example, I don't know, maybe use 2 timers for each circuit, and the first one from 0 to let's say 10 kilo, and we will have a problems that inside the interval you will not be able to control the whole values. So it's very hard, for example, to get 1 kilohertz purely. But now with this idea, it's very easy. So now what to do to change or to get values in each interval alone? In each individual interval, we use this potentiometer. Very simply, you can get any value. For example, if I connected the capacitor of value 1 microfarad, and then I can get from 1 to 10 hertz very purely. Of course, this is ideally because there is a problem of manufacturing tolerance. It's very high indeed here in Turkey, at least. For example, you want a 1 microfarad, you get a tolerance 20%, which is very high and will affect your project. Now, finally, I will make an example. Okay, now getting the right voltage, it should be between 4 volts and 13 volts, otherwise the circuit will be burned because it cannot compensate with such voltage. Okay, now as I said, instead of getting a battery, I now have my own voltage from immediately from the house electricity. So I put the voltage in the right polarity. We have to pay attention to the polarity, otherwise, because capacitors, for example, are polar components, and I will have problems. And this is now the probe of the oscilloscope, and oscilloscope as we can see, we are getting now a pure, very pure. This is also a good thing, and we will see now in higher ranges that this purity will not be decreased in a very large amount. So this is the square wave. Now let's try to get change the hertz inside the range. Now I'm in the range of 1 hertz to 10 hertz. Let's do the measure, okay, to see the value of the frequency. Now it's 12 hertz. Okay, you might ask why not 10? Well, simply because of, as I said, there is a tolerance, a very high tolerance, that we are having problems due. Okay, now we can see that we are making the frequency bigger, 7, 6, as you can see. Okay, now let's check the other technique, the interval switching technique, using this switching capacitor. Okay, I will now, it was clicked or switched to the next level. We can see now the frequency, and it cannot measure the frequency like this, so I will have to make this, yes. Okay, now it's 96 hertz. Okay, let's change. 80, 70, you can go higher. As I can see, it's working well. And the same for the pseudo sine and the triangular wave. And it was let's say a successful project, and we got good notes on it. Thank you. I hope that this tutorial was useful.